Hi, I'm Tom Loschiavo, the Chemistry Education Manager at PASCO Scientific, and I'm here today to talk about the PASCO Polarimeter. So the polarimeter is a device used to measure the rotation of plane polarized light by optically active compounds. So before I get into the polarimeter, I just want to tell you a little bit about what that sentence means. So assume this is a compound with a central atom and 4 different atoms attached to it. This is the same central atom with the same 4 different atoms attached to it, but these are actually different compounds. These are non-superimposable mirror images of each other. They look the same, mirror image, but I cannot superimpose the two. These are called enantiomers, and these enantiomers, these 2 enantiomers, happen to have a chiral center, and that chiral center will rotate the plane polarized light either this way or this way, depending on the compound. So what does that mean, plane polarized light? Well, I can demonstrate that over here. So I have a light source in the back. I have a polarizing film. I have a sample of water. And I have another polarizing film. And you notice when I turn the first polarizing film that the sample and the film around it get darker. Right? The water is not having any effect on the brightness of the light. But if I take that same light and I run it through a sample with a chiral center, in this case Karo syrup, then you'll notice that in this case some wavelengths of light are getting blocked while others are getting through. So now, as this is getting darker, this is getting brighter, different colors are starting to appear because of the different wavelengths of light that are being blocked or let through by that particular sample. So that's what I mean by rotation of plane polarized light. This is rotating the light, this is not, because there are chiral centers in the compound. Now what we want to do is we want to quantify that. So to quantify that, we're going to use our polarimeter. Polarimeter, simple turn on power button right here. It can be connected via Bluetooth or USB. Inside, there is a sample cell holder. And here's a sample cell. So this sample cell just has water in it, but it's a 100 millimeter sample cell with quartz ends, so it won't affect any of the light. In the polarimeter, there is a 589 nanometer monochromatic light going through a polarizing film on this end and a polarizing film on this end in front of a detector that I can rotate around just like I could rotate this around. So I have monochromatic light that's getting plane polarized, going through my sample, and hitting a detector. So what I'm going to use is I'm going to use some PASCO software. And you can use either SparkView or Capstone. In this case, I'm using Capstone. And I'm going to try to figure out the exact angle of rotation where I get the most intense light to come through my water sample. And then I'll do that again with a sample containing a chiral compound. And we'll see how we can measure that angle of rotation based on the chiral compound that's in there. So over here I have my polarimeter attached to the software. I have a graph of intensity, light intensity versus the angle. So I'll be able to measure the angle rotation. And I'm just going to hit record. And I'm going to start spinning the wheel. And you'll see that there's my plot of intensity versus angle of rotation. There we go, a nice plot. And what I'm going to do is I'm going to go from 0 to 360 degrees a couple of times, just rotating around, to make sure I have lots of good data to get a good fit on so that I can really pinpoint that exact highest intensity, the angle at the highest intensity. Now spin it around a little more. And there we go. A couple of cycles through, and we got through our 360. And I'm just going to hit stop now. So now I'm going to take this sample out. If you're doing this as an actual experiment, you probably want to use the same sample holder each time, but for this purpose I'm just going to use a different sample holder. I'm going to put this in, and this has a sucrose solution in it. So I'm going to start recording again. And again, I'm just going to spin the wheel. There we go. Notice the intensity is a little different, and that makes sense. There's something in there. But also notice that the peak intensity is shifted slightly from where it was before because, just like this, there is an optically active chiral compound in there that will shift that the plane polarized light. So I'll spin this around a little bit. The wheel on here has a notch in it, so you know where you start and end to make sure you're going around at least once. You can also look at the graph to see that you're going from 0 to 360. And once I get to 360 a couple times, round it out, I'm going to hit stop. And now I'm going to do some analysis, and this is where the software comes in. So I'm going to try to find the peak intensity here and here. To do that, I'm going to highlight an area. This is my run 2. And I'm going to apply a fit to this. Apply a Gaussian fit. And this x naught is my angle at the highest intensity for that particular set of data. Now I'm going to do the same thing with my first run, which was the blank, which was water. I'm going to highlight some data. I'm going to turn on my fit again. And now I have my Gaussian fit for both of those samples. So my blank water, the sort of zeroing or blanking based on the water was at 75.9 degrees. And the rotation for the sample of sugar was at 81.9 degrees. So it looks like based on the concentration of sugar in there, I had a 6-degree rotation. The other nice thing about this, so you can do this with multiple concentrations. This is actually a good way to introduce concentration. The concentration, the specific rotation of your sample will depend on the path length, which we've used industry standard sample cells to make sure you have a very specific path length. And it'll also be based on the concentration of the sample. So you can look at concentrations of samples as a function of optical rotation as a novel way to introduce concentration. The polarimeter is a great way to talk about concentration, and it's also a great way to talk about the differences in molecular structure. So using the PASCO Polarimeter and some PASCO software like Capstone and SparkView, you can really get a handle on optical rotation of chiral compounds. Thank you very much. This has been Tom Moschiavo. You can reach me at chemistry@pasco.com, and I'd like to encourage you to think science.